Hello everybody, this is Mr. Bowman. So today we're going to be looking at the ALEKS topic, simplifying a radical expression with an even exponent. So we have a square root here. Notice there is no index in our radical sign there, so we can assume that is a 2 and makes it a square root. It's kind of our default. So to figure out what we're going to do, I need to break apart the 50 and the y to the 6th, and I can do those separately. So for the 50, I'm going to make a little factor tree here and pick two numbers that multiply together to get 50. It doesn't matter what you pick here. You should end up with the same thing. So I'm going to pick 5 and 10. 5 is now prime, so there's nothing that's going to break it down there except 1 and 5, and it's not going to get me anywhere. So I can stop. It's the end of that branch. 10, on the other hand, breaks down to 2 and 5, which are then both prime. So that means 50 equals 5 times 2 times 5, or if I put them in order, 2 times 5 times 5. Okay, and you can always just multiply those together to make sure you did it correctly. And if you did it differently, maybe you said 50 is 25 times 2 instead of 5 times 10, you'll end up with the same thing down here, and this is known as the prime factorization. And there's a unique one of those for every number. So no matter what you do with 50, if you do it correctly, you'll end up with 2, 5, and 5 in some order. So I'm going to take that, and then I'm also going to look at y to the 6th, which you could make a factor tree if you want, but there's no real reason to, since we know that y to the 6th means it's y multiplies by itself 6 times. So I'm just going to write y down 6 times. 1, 2, 3, 4, 5, 6. There we go. Yep. All right. So I'll take this off too because that's not technically accurate because I had the y's. So 50 y to the 6 is 2 times 5, 5 times y, 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 y. Now, why would we do that? Because this 2 is telling us how many like objects we need in order for it to get pulled out. So I'm going to circle sets of 2 matching objects. So I only have 1 5, so that, or 1 2, so that doesn't work, but I have 2 5s, so I can circle those. So I'm going to circle another 2 y's there, 2 y's here, and 2 y's here. So that index number there tells me how large of matching sets I need. Okay. So since it's a 2, I need 2 matching sets, so 2 5s, 2 y's, whatever. So then to simplify this information gives me everything I need. Any circled numbers are going to come out front, and any non-circled things are going to be stuck on the inside. So you have to be careful here. When I'm looking at each circled thing, though, I'm going to pull one object that is respective of the entire group. So for this, I'm going to pull out a single 5. For this one, I'm going to pull out a single y, and a single y. So I have 5, y, y, y is going to be outside, and these are all multiplied. Okay. And then this 2 that I couldn't use is still in that square root. So then I want to clean this up because 5 times y times y times y, I can clean up just a little bit and say 5y cubed times the square root of 2. And that is the simplified version of the square root of 50 y to the 6th. Now, just a quick note here. Why is that simplified? It doesn't look any more simplified. It looks like there's more stuff. When we're talking about simplifying a radical, we're looking for that inside of the radical, that radicand, to be as simple, as small as possible. So we made it go from 50y to the 6th to a simple 2, which is why that's considered more simplified than that one.